We've seen a number of examples of recursive functions, something you're going to use a lot. But all of them so far have just been numerical. So let me show you one more example that I can do recursive problem-solving recursive functions on other things, for example, on strings. So here's the challenge. How would I tell if a string of characters is a palindrome, meaning that it reads the same forwards and backwards? Now I'm going to cheat a little bit and remove punctuation and capitalization, but I just want to know, is something a palindrome? Probably one of the most famous, attributed to Napoleon, although I don't know that he said it in English, was able was I ere I saw elbow. If you look at it frontwards or backwards, it reads out exactly the same. Second one, attributed to Anne Michaels. Are we not drawn onward, we few, drawn onward to a new era? And you can see if I read it from right to left or left to right, it's exactly the same. I'd like to write a piece of code that can solve this recursively. And you can think about doing it iteratively, but recursive is so much better a solution to use. So how would I do it? Well, I'm going to do a little bit of cleanup first. I'm going to convert the string to just the characters. I'm going to strip out any punctuation, and I'm going to convert lowercase or everything from uppercase down to lowercase. So I just have it all as a sequence of characters. And then I've got a very simple solution. If the string is empty, it's a palindrome. If it's just of length 1, it's a palindrome. Otherwise, how would I tell if some string is a palindrome? Well, check the first and last element. If they're the same, then check everything in between to see if it's a palindrome. That's cool. That's a recursive solution. I've just broken it into a simpler version of the same problem. And of course, as I keep breaking it down, eventually I'm going to get down to either a string of 0, if the whole thing started off as even, or a string of 1, if the whole thing started off with an odd length. Can I do that? You bet. I'm simply going to write a little piece of code that's going to say, if I've got a piece of code that's called is it palindrome, I'll first convert this just into the string. I strip out all the separate spaces, the punctuation. I remove uppercase to lowercase. And then, as I said, if the first and last element are the same, then I just want to check, is that a palindrome? And there's the code. Nice and compact, nice and simple. I'm not going to walk through all of it, but you can see the first part here is simply something that's going to convert that string into characters. It takes advantage of a property of strings that I can call a method called lower that will convert everything into lowercase. And then I've just got a nice little iterative loop here that basically walks through each character in the string. There's that iteration over the string itself. It's a string iteration. And it basically says if that character is, in fact, a character, add it in. And then there's that nice, elegant solution to palindromes. It says given one of those strings, if it's of length 0 or less, if it's of length 1 or less, it is a palindrome, return true. Otherwise, check the first and last. There's that call with -1 to a string, the first and last character of the string. And check by slicing out from the string everything but the first and last character and see if that's true. And finally, I'll just convert the string and call isPal on it. Let's try it out. I've got those two characterizations over here. I've got it loaded up, and if I call it, it says, is, for example, a simple thing like Eve a palindrome? You bet. EVE is a palindrome. And what about is able was I ere I saw elbow a palindrome? You bet. Again, notice how thinking about it recursively has let me find a really nice solution to this problem. This is a very crisp piece of code that solves what otherwise seems like a very hard problem. Could you solve it iteratively? Sure. But you'd have to keep track of where you are on both ends of the palindrome as you decrement them to walk in. That sounds like a pain. I'd much rather think of this recursively, and that's what I did. This is, as to all the previous examples, but this is a really nice example of what we call a divide and conquer algorithm. I solve a hard problem by breaking it into a set of other subproblems that have the property that they're easier to solve than the original, in this case it's shorter, and that the solution of the subproblem can be combined to solve the original problem. We saw that with factorial, we saw it with other ones. This is a great example of it. And we're going to come back to this idea of divide and conquer algorithms as we go through the course, because they're a very powerful pattern that we want to be able to use.